Hello and welcome everyone to the second video as part of the Recursion Primer series, Nth Fibonacci Number. First, we have to understand what is a Fibonacci series or what's a Fibonacci number. So, Fibonacci series, as we can see over here, is a series of numbers which follows this sequence. If you notice, it starts from 0, then it goes to 1, and after 1, every number is equal to the sum of the previous number and the previous to previous number. Means, if we are at 1, this one is nothing but 1 plus 0. If we see this number 2, this is nothing but 1 plus 1 is 2. And number 3 is 2 plus 1. Means it is going 2 steps before, means n. If this is n, so we can think of it like if this is n, the given number, then this is n. Okay, so in order to find out what this value will be, we have to do n minus 1 plus n minus 2. That is what is given here in the mathematical terms. This is defined by function of n, which is equal to function of n minus 1 and function of n minus 2. And the seed values are f of 0 is 0, f of 1 is 1. What is seed value? Seed value is something which is already known or which is already given to us. We know that if f of 0 is the Fibonacci method is having 0 as the argument, or if n is equal to 0, then we have to return 0. If the argument is 1, then we have to return 1. That's it. So these two numbers are already given to us. So these two values are already given to us. On the basis of this, we have to determine what is the nth Fibonacci number. Means we have to determine, let's say, if n is equal to 3, we have to find what is the third Fibonacci number. If you come back to the sequence, the third Fibonacci number, how can it be determined? If this is 0 and this is 1, 0, 1, 2, 3. The third Fibonacci number is in this series is 2. So now let's try to understand how can we solve this question. Okay. So as we have told, if we have to solve this question using recursion, we first have to define a base case and then we have to come to the main body of this. First, let's talk about the base case. As we are already given the seed values, means we can understand that whenever the f of 0 comes, whenever this function is having n equal to 0, okay, or when it is equal to n is equal to 1, then we simply have to return whatever the n is. If it is 0, we'll return 0. If it is 1, it will return 1. That is the base case. Why? Because when I'm reaching over 1, over here, when I'm reaching already the number, the n equal to 1, or I'm reaching n equal to 0, I cannot go beyond that. This is where my recursion has to stop. There is nothing negative number or something. So since it is starting with 0, this has to be a base case. And since the seed value is also f of 1, if we already get 1 as n, we have to return 1 because 1 is not equal to 0. So what I mean to say is these two numbers are not actually following the summation rule. That 1 over here, if you see, this 1 is given. It's a provided number. It is not following the rule of Fibonacci, and it cannot follow also because it needs n minus 1 and n minus 2. There are no two numbers before 1. And of course, in 0 is the starting point. It cannot also follow this mathematical equation, which is why these two are going to be our base cases. So our base case will be if n is equal to 0 or n is equal to 1, we have to simply return the n. Okay, now coming to the main body. So for deriving the main body, we have to understand or take a look at we have to understand this mathematical sequence first. What it is saying, we have to, in order to find out n, so in order to find out n, we have to understand or we have to do a summation of n minus 1, whatever that number will be, plus n minus 2. This is what is being told to us. So at any given point in time, whatever my n is, that n can be achieved by doing a summation of n minus 1's number and n minus 2's number. So how can we write that? So we can say return this, whatever this method is, we are calling this method, but in this case, we are calling n minus 1. And we are adding it up with again the same, this method, and then we are passing n minus 2. Which means whatever this method is giving to us n minus 1 and whatever this method is giving to us n minus 2, we are combining the results of this, and that is what we are returning to every invocation of n. So what we are saying is whenever fn is happening over here, fn, it is going to give me a combination of f of n minus 1 and f of n minus 2. Combination means the summation of these. When I get the summation of this, then I will be able to find out what exactly should be the value of this method. If I have to do a dry run, like I have done n equal to 5. So what is n equal to 5? 0, 1, 2, 3, 4, 5. Okay, so this is my, if my n is 5, this is what my number will be. This is going to be the fifth number in the Fibonacci series. If this is the fifth number in the Fibonacci series, or let me just try to change this number. What is the seventh number? 0, 1, 2, 3, 4, 5, 6, 7. Okay, so if n equal to 7, then we should be getting 30. If that's the case, how we are arriving? 13 is essentially equal to 8 plus 5. That much we know. How are we getting 8? Is we are getting by adding 5 and 3. So it's not our headache how we are getting 8, how we are finding 5. The smallest problem, like I have told in the primer series, the first video of that, recursion is happening in order to solve the smaller subproblem first. What is my smaller subproblem? I have to add this plus this. After that, what is happening? Before that, what is happening? I do not care much. My smallest subproblem is if I have to get 13, I have to add these two. Now, I have to add these two. Now, how will these two come? Is what? Is the another smaller subproblem. So, we are breaking this bigger problem into smaller subproblem, and that is where recursion is coming into the picture. Okay. So, with that, let's try to now run this. And we got it as 30. Okay. So, in this way, with just 2 lines of code, we can find out the nth Fibonacci number. So, with just 2 to 3 lines of code, we are able to solve this question. So, that's all about this question. Thank you so much for watching. Do let me know in the comments below if you have any suggestions or doubts about this series. And please don't forget to subscribe to my channel in order to be updated on further content like this. Thank you so much.